Okay, this is number 69 from chapter 2. In this problem, they give us a hill that we can assume is constant in slope because they tell us we have constant acceleration. And we have two segments to this. So this is a problem where one of the tricks is going to be to break it up into part A and part B. And they give us the following information, that the two intervals occur at 0 seconds to 5 seconds. And then part B is traveled in the second 5 seconds, so from 5 to 10 seconds. And in the course of part B, the ball travels 150 meters. And we are asked, what is this first distance for delta for A? So, to tackle this problem, now that I have those two parts, we can make that show up. There we go. I'm going to look at the first section. Well, first off, the first thing you need to realize is that the velocity at the end of part A is going to be the same as the velocity at the beginning of part B. So to help us break that down, I'm going to actually call this here point 1. This here is point 2, and this here is point 3. So what I'm basically saying is, for the first half, for part A, V2 could be found as, if I take a look at just the simple equation that V2 minus or equals V1 plus AT. For part A, V1 is 0. The object starts from rest. I know I have 5 seconds, so V2 is 5A. So that's the velocity at point 2. Now the reason I want that is this is the starting velocity for part B. So now I'm going to take a look at what's going on in part B. And I'm going to use the equation delta x b equals v2 times t plus a, 1/2 a t squared. Delta xb is 150 meters. V2 is 5a. The time we have is 5 seconds, meaning the total for time interval for part B is 5 seconds, plus 1/2 a times 5 seconds squared. If I solve this equation for A, I get a value of 4 meters per second squared. And that's the acceleration for the entire ramp. And that's because the ramp is straight, and they tell us that in the problem, that it's constant acceleration. So now that I have the acceleration for the whole time, I can go back to part A and find the distance. I'm again going to use this equation, delta x, so we're doing this for part A, is now going to be v1t plus 1/2 at squared. This equation is a little easier since the ball starts from rest. This first term goes away. And delta xa equals 1/2 4 meters per second squared times 5 seconds squared, and that's 50 meters. And you're done. This is the end of number 69 from chapter 2.